Hi, in this video, I will be showing you problem number 13 of chapter 5, section 3 from the practice exam. Use part 1 of the fundamental theorem of calculus to find the derivative of the function. Fundamental theorem of calculus states that, part 1 states, if g of x is an integral a to x ft dt, where a is a definite limit, x is a variable, then the derivative of g of x with respect to x is the integrand with the variable t replaced by the upper limit x. Now in this problem, let's consider h of x, which is 1 through e to the x, 3 ln t dt. Note here, lower limit is a definite limit, upper limit is not just x, it is e to the x. So let's make a substitution here, u equal to e to the x. Then du by dx is e to the x. And also when we do the derivative, so it is when you do h prime x, which is what the question is, you have to find out the derivative. You are actually differentiating with respect to x. So d by dx of hx. But h of x depends on the variable u, and u in turn is a function of x. So it is kind of function of a function. So whenever you do function of a function, you are going to use the chain rule. So we're going to write this as d by du of h of x times du by dx. This is by chain rule. So we are going to do this in two steps. So here we are going to write h prime x, which is equal to d by du. So we are going to write this as d by du of integral 1 to u 3 ln t dt, because we are assuming u equal to e to the x, and then times du by dx. So we are doing this part is this part, then this part is this part. So it is going to be equal to, so this is like your regular fundamental theorem of calculus. So it is derivative and integral, they get cancelled out. So you get the integrand with the variable t replaced by the upper limit. So it is 3 ln of u, where u is e to the x. That is this part. And then du by dx, which is e to the x. So it is this part. So now we know that ln and exponential and ln are inverses of each other. So ln of e to the x will be just x. So it is 3x and then e to the x. Hope this video helps.